Hi, in this video we're gonna look at Simpson's rule and we're gonna create a program using MATLAB that will calculate Simpson's rule for some examples in this book. So this is my calculus book and it has Simpson's rule here, and this is the equation. It's named after this mathematician, Thomas Simpson. So this is the equation for it. It says S is delta x over 3 times this long summation. It goes from y naught to y sub n. So where n is even and delta x is b minus a over n. So notice it goes 4, 2, 4, 2, 4, 2 all the way to y sub n. So those are all even ends. Okay, so let's jump to MATLAB. So I made a comment that this is what we're doing. The program is called Simpson's Rule, and it's on page 523 of my textbook. And I formatted short, and I have some examples that we will try and test when I make the program. So first things first, let's borrow one of these functions. So I'm going to copy it and paste it here. So x is a linspace from 1, 3, 5. So this 5 would be the intervals, but it's n plus 1. So the intervals n would be 4 in this case. Even though it's 1, 3, 5, it's n plus 1. And this is our function. It's y equals 2x minus 1. That's one of the problems in the book. It's number 2 in there. All right, so the next line of code, we're going to say n equals length x. So we get the length of x of the vector up there. And then next, we're going to create a vector that will calculate that will have ones at the end and have the even numbers in between. So we're going to say a equals 2 times ones, and this is n comma 1. And then we can say a sub 1, a of 1 equals 1. So that puts a 1 there, and we can say a sub n equals 1. So those are the ends, those are ones, and then a of 2 n minus 1 equals 4. That puts the 4 in the middle of the sigma notation. So that's 4, 2, 4, 2, and so on. And then we're next gonna say t equals 0, initialize the summation for Simpson's rule. And we're going to say we're going to have a for loop. So for I equals 1 to n, we'll have t equals t plus a sub I. And this is multiplied by y of I, like this. All right, and that's it. That's all we do in the for loop. And next, we need to have the delta x divided by 3, just like the equation. So we'll say t equals x of 2. This is minus x of 1, like this, and multiplied by t, obviously. That's this long summation, and divided by 3, just like in the textbook. It was delta x times the long summation over 3. And this is how we calculated the summation, the long summation. We're gonna increment and account for each time that we have a sum up to n times. All right, so that's all there is to it. Let's go ahead and run this program. So the first example is 2x minus 1. That would be number 1 of this textbook. If I come all the way down, so we have, let's see, it's actually number 2 in here. 2x minus 1, its integral from 3 to 1. And the answers I have is on Quizlet, but I'm not going to check it. But the answers we get here match the ones in Quizlet. So let's go ahead and run it. And we get T6. So that's the Simpson's rule for the integral from 1 to 3, 2x minus 1. All right, let's do another problem. So we're going to now do this one. So this is number 3 in the textbook. We're going to copy it and paste it in here. and run it, see what we get. So t is 2 2/3, 2.666, and so on. All right, maybe let's see if we change this. Oops, if we take the comment and run it again, it's still 2.666 format short. Didn't change much, so maybe do a format short G like this. Yeah, okay. All right, so let's do a last problem. So this is the last problem. This is number 9 in the textbook. I'm gonna copy it and paste it here, and when we run it, we get t is 2.0046 for the function y is sine x, and our bounds are 0 to pi with n equals 4. So it'll be 5 intervals, starting with y naught is 0. All right, so that's how we create a Simpson's rule program using MATLAB.